Hi, imagine you are building the next big social media platform and users are constantly trying with their different usernames, which checks whether the given username already exists in the database or the given username is available to be used. Now assume your database has 100 million such users. So do you really want to check your database every single time someone types a username? Of course not, because that is slow and cost more money. So what if I told you there's a data structure that can tell you that the item you searched is definitely not in the database or it might be present in the database, and it uses very minimal memory as well. Meet the Bloom filter, today's topic of the video. So Bloom filter, as I said, is a data structure that is space efficient, probabilistic, that is used to quickly test whether an element is possibly available in a set or definitely not available. So let's understand it with an example of a pharmacy store. A customer with a prescription goes to a large pharmacy store having more than, let's say, 15,000 different medicine, and he asks for a medicine out of that prescription. So now the worker of that pharmacy would go check the stock and bring the medicine if available. But what if the medicine is not available? Searching consume time, right? But with a result, what? Not available. So in a busy large store, time consumed for all such customers would impact the efficiency of their business. And similar would be the case for our database as well. Large sets of data would be queried even if the result would be not available. So here is how Bloom filters come to the picture. It is an array of bits with a length of n elements, each element storing either 0 or 1. Now, whatever data is being stored, it will pass through a hash generator function that generates a hash value. In our case, let's say when a medicine named crocin is being stored to the stock, it first passes through a hash function which generates a hash value 21. This will turn on the 21st index of the array. Now, same thing happens when a value is being searched. So whenever a value named crossing will pass as an input to the hash function, hash generator function, its value would be the same 21, which will be further checked in the array. If that index is turned off, the value is not available, and which is for sure. And if turned on, it is available. So that's how Bloom filters work. Now in that case, let's say if in case of negatives, if the hash is not present, the data search is not available. But if in case of positives, it may happen that some other input value could also generate the same hash value 21. So if searched, it may give a result available, but it's possible that it may or may not be available. This is a limitation of Bloom filters, that it allow false positives. But we have a way out of it to improve the accuracy. What we can do is we can use multiple hash generators. Let's say we have three hash generators, each producing different hash values. Let's take the same medicine example, crocin. While getting stored gives three different hash values, 21, 18, 23, which will turn on all these three indexes of the array. And now on searching crocin, all these three hash values generated from their respective generators will be checked in the array, and when all three are on, they can say the data is available. Else if one out of these three was off, we can say data is definitely not available. So how it improves accuracy? It's because, let's say, some other value is searched like ORS. Though one hash produced is same, that is 21, but the other two are not same and their indexes are also not turned on in the array. Hence we can say that it is definitely not available. So now let's talk about real world applications. Starting with web browsers, they use this for bad websites. Like before expensive security checks, it checks whether the site is definitely safe to skip the security check or not. Big databases use this before slow disk operations. It checks that is this user record definitely not stored in this data file. If not, skip the expensive disk read. Online stores use this for product searches. Like, does this customer's search definitely not match any product in this category? If yes, keep checking this entire product group. Email systems use this to quickly skip obviously good emails before running expensive spam checks. Now let's look at the advantages of Bloom filters. So the first advantage is they are space efficient, because instead of storing the actual data, Bloom filters just store a bit array, which means they use much less memory overall. Second, they offer fast lookup times, because checking if an item might exist is super quick, making them perfect for real-time systems. The third one is they never give false negatives. So if the filter says an item is not present, you can be absolutely sure. That's a guarantee. And lastly, they are highly scalable as well, because even when you are working with massive data sets or distributed systems, Bloom filters perform really well. But of course, like any technology, there are limitations in this as well. First is they can give false positives. This means the filter might say an item exists even when it actually doesn't. It's a trade off for that space and speed. Second, you can't retrieve actual values from it, because Bloom filters only tell you whether an item might be present. You can't pull the data back out. And the third one is you need to define the size in advance. You have to tune the size of the filter and the number of hash functions before you start using it. And that can be tricky if you don't know how much data you'll handle. So yeah, that's it all about Bloom filters. Thank you.